Not, however, necessarily here in London, for we have already seen that air travels as wind all over the world, rushing in to fill spaces made by rising air wherever they occur. And so these clouds may be made of vapor collected in the Mediterranean, or in the Gulf of Mexico, off the coast of America, or even, if the wind is from the north, of chilly particles gathered from the surface of Greenland ice and snow, and brought here by the moving currents of air. Only of one thing we may be sure, that they come from the water of our earth. Sometimes, if the air is warm, these water particles may travel a long way without ever forming into clouds, and on a hot, cloudless day the air is often very full of invisible vapor. Then, if a cold wind comes sweeping along high up in the sky and chills this vapor, it forms into great bodies of water dust clouds, and the sky is overcast. At other times clouds hang lazily in a bright sky, and these show us that just where they are the air is cold and turns the invisible vapor rising from the ground into visible water dust, so that exactly in those spaces we see it as clouds. Such clouds form often on a warm, still summer's day, and they are shaped like masses of wool, ending in a straight line below. They are not merely hanging in the sky. They are really resting upon a tall column of invisible vapor which stretches right up from the earth, and that straight line under the clouds makes the place where the air becomes cold enough to turn this invisible vapor into visible drops of water. And now, suppose that while these or any other kinds of clouds are overhead, there comes along either a very cold wind or a wind full of vapor. As it passes through the clouds, it makes them very full of water, for if it chills them, it makes the water dust draw more closely together, or if it brings a new load of water dust, the air is fuller than it can hold. In either case, a number of water particles are set free, and our fairy force, cohesion, seizes upon them at once, and forms them into large water drops. Then they are much heavier than the air, and so they can float no longer, but down they come to earth in a shower of rain. There are other ways in which the air may be chilled and rain made to fall, as, for example, when a wind laden with moisture strikes against the cold tops of mountains. Thus the Acacia hills in India, which face the Bay of Bengal, chill the air which crosses them on its way from the Indian Ocean. The wet winds are driven up the sides of the hills. The air expands, and the vapor is chilled, and forming into drops falls in torrents of rain. Sir J. Hooker tells us that as much as 500 inches of rain fell in these hills in 9 months. That is to say, if you could measure off all the ground over which the rain fell, and spread the whole 9 months' rain over it, it would make a lake 500 inches or more than 40 feet deep. You will not be surprised that the country on the other side of these hills gets hardly any rain, for all the water has been taken out of the rain before it comes there. Again, for example, in England, the wind comes to Cumberland and Westmoreland over the Atlantic, full of vapor, and as it strikes against the Pennine Hills, it shakes off its watery load, so that the Lake District is the most rainy in England, with the exception perhaps of Wales, where the high mountains have the same effect. In this way, from different causes, the water of which the sun has robbed our rivers and seas comes back to us, after it has traveled to various parts of the world, floating on the bosom of the air. But it does not always fall straight back into rivers and seas again. A large part of it falls on the land and has to trickle down slopes and into the earth in order to get back to its natural home, and it is often caught on its way before it can reach the great waters. Go to any piece of ground which is left wild and untouched. You will find it covered with grass, weeds, and other plants. If you dig up a small plot, you will find innumerable tiny roots creeping through the ground in every direction. Each of these roots has a sponge-like mouth by which the plant takes up water. Now, imagine raindrops falling on this plot of ground and sinking into the earth. On every side they will find rootlets thirsting to drink them in, and they will be sucked up as if by tiny sponges, and drawn into the plants and up the stems to the leaves. Here, as we shall see in Lecture 7, they are worked up into food for the plant, and only if the leaf has more water than it needs, some drops may escape at the tiny openings under the leaf and be drawn up again by the sun waves as invisible vapor into the air. Again, much of the rain falls on hard rock and stone, where it cannot sink in, and then it lies in pools till it is shaken apart again into vapor and carried off into the air. Nor is it idle here, even before it is carried up to make clouds. We have to thank this invisible vapor in the air for protecting us from the burning heat of the sun by day and intolerable frost by night. Let us for a moment imagine that we can see all that we know exists between us and the sun. First, we have the fine ether, across which the sunbeams travel, beating down upon our earth with immense force, so that in the sandy desert they are like a burning fire. Then we have the coarser atmosphere of oxygen and nitrogen atoms hanging in this ether, and bending the minute sun waves out of their direct path. But they do very little to hinder them on their way, and this is why, in very dry countries, the sun's heat is so intense. The rays beat down mercilessly, and nothing opposes them. Lastly, in damp countries, we have the larger but still invisible particles of vapor hanging about among the air atoms. Now, these watery particles, although they are very few, only about 1/25th part of the whole atmosphere, do hinder the sun waves, for they are very greedy of heat, and though the light waves pass easily through them, they catch the heat waves and use them to help themselves to expand. And so, when there is invisible vapor in the air, the sunbeams come to us deprived of some of their heat waves, and we can remain in the sunshine without suffering from the heat. This is how the water vapor shields us by day, but by night it is still more useful. During the day, our earth and air near it have been storing up the heat which has been poured down on them, and at night when the sun goes down, all this heat begins to escape again. Now, if there were no vapor in the air, this heat would rush back into space so rapidly that the ground would become cold and frozen even on a summer's night, and all but the most hardy plants would die. But the vapor which formed a veil against the sun in the day now forms a still more powerful veil against the escape of the heat by night. It shuts in the heat waves and only allows them to make their way slowly upwards from the earth, thus producing for us the soft, balmy nights of summer, and preventing all life being destroyed in the winter. Perhaps you would scarcely imagine at first that it is this screen of vapor which determines whether or not we shall have dew upon the ground. Have you ever thought why dew forms, or what power has been at work scattering the sparkling drops upon the ground?